All right, I'm going to click record and then let's go ahead and do it.
All right, welcome everybody back to Paleo Talks. We have had a few technical difficulties today, and I'm actually on here twice. So as I'm looking at you today, I may be looking at you in a different direction. But everything seems to be working, and David has managed to get through technical difficulties as well. And Chris and I are going to talk today about Saltville and our experiences in Saltville. Our catchy title of the day is something like Ice Age Monsters of Saltville, Virginia. And so we're going to tie in the monster aspect as well with these megafauna. But we're going to walk you through the history of this fossil site. Sort of when were the first discoveries and how did we get involved in the research in this magnificent place? We're coming to you again from the Center of Excellence in Paleontology at East Tennessee State University, which oversees the Great Fossil Site, but we also oversee the excavations at Saltville as well. And so we're getting around to telling you all about that. And of course, my battery is going to go off, and then you can't see me do that one.
Well, Blaine, while you figure that out, I'll go ahead and explain how it's going to work. And if we end up losing Blaine's video, then we'll just have his voice. So, as usual, we're going to start with our presentation. Today, it's just the core Paleo Talks crew. It's me, Blaine, and Chris. So Blaine and Chris, of course, are two of the big heads of the Saltville Excavations. As always, we're going to let them go ahead, explain the science, and then towards the end of the program, we're going to make it Q&A led. So audience questions for the remaining section of the program. So at that point, we will remind you to go ahead and submit us your questions. You can leave them in the comments of the Facebook video, or if for any reason you can't leave a comment on Facebook, I'll be keeping an eye on the Gray Fossil Site accounts on Twitter and Instagram, so you can head over there as well. Blaine, you're back.
All right, thank you, David. I'm back for now. Let's see how long it works. Here we go. All right, let me share my screen, and we'll jump right into it. You guys can see that, right?
Yep.
Okay, so this is the Saltville Valley, just this absolutely gorgeous place, the town of Saltville, Virginia, about an hour and a half north of here, not too far off of Highway 81, and you can see signs along the highway actually for their museum over there and go and visit their little museum that's in this valley. So just a gorgeous, picturesque little valley here. Let's see. Here we go. And, you know, we've been talking about the Pleistocene. We've been talking about, we can call them these monsters in many ways from the Pleistocene, these large, large animals. And so Saltville actually lets us approach a lot of these questions that we have with the megafauna of the Ice Age itself. You know, Chris, what are we talking about when we say Ice Age and how long of a time frame the Ice Age is?
Well, by definition, we're talking about the last 2.5 million years up to about 11,500 years ago. Lots of, we say it's the Ice Age, but it really goes back and forth between warm and cold multiple times. And what we have in Saltville, we'll get into a little bit of that later, but certainly some of the colder periods are represented at Saltville.
That's right. That's right. And we used to have like 4 main interglacials, glacials that we talked about, but now it's up in the 20s, I guess, or something like that. Is that correct?
Yeah. There's a lot of them. In fact, there's some recent research that's modeling all the way back to like MIS 21 and that sort of thing. So really far back we can get at the coverage of the ice and that.
Tell the audience what you mean by MIS.
Oh yeah. So how we tell time during the Pleistocene often is according to the marine isotope stage. So these correspond to parts of the ice core, and whether we're talking about a warmer interglacial or we're talking about a cold glacial. So glacial advances we call glacials, and the warm parts in between we call interglacials.
All right, thanks for that, Chris. And so it's all these megafauna that, you know, for many of us, it's what's captured our attention with this near time extinction and what used to be here. And we can see over on the right, you know, some of these different megafauna, including giant ground sloths, mammoths, mastodons, camels here in North America, giant beavers, oftentimes said to be as large as a black bear, and then these glyptodont-like animals. And then we can't forget about the fact that people are also starting to show up at that latest part of the Pleistocene. And so it's with these sites like Saltville that we can really address these kinds of questions, like what were the environments and that these animals lived in, and what kind of diets did they have? When did they go extinct by using different type of dating techniques? How does this timing of these extinctions tie in with climate change? And also, what about humans and when did they show up, and what did this impact have on the megafauna? And wow, just a paper came out. Was that just yesterday that paper came out, Chris, that Meltzer published?
No, that was, it's been out for a month or two now.
Okay.
But yeah, looking at how these animals kind of contract or go extinct, a series of extinctions over the last couple of glacial to interglacial transitions. So yeah,
And that's something you and I've worked on, is, you know, trying to date these latest occurrences in many cases. And so it was cool to see that paper just yesterday. And that's something we can maybe reference here on Facebook at some point, is that new paper by Meltzer. But when we look at that overall sort of North American fauna, this megafauna of animals in this landscape, we wouldn't have gone to a place to see all of these animals like this in this close proximity. But when we get to see them all together like this, it really drives the point home when we then change it to this scene where you're seeing all of those ones that went away, all of these large animals that went extinct. And if we look at then what actually is found at Saltville of these animals, we have what's in black. And so you can see all of these different genera. We used to say about 33 of the megafauna in terms of genera went extinct. In adding to this last night, I added the direwolf, now that we're basically placing that back in its original genus of Aniscion. And we'll talk about why we might have that at Saltville. So the ones in black are ones that we know we have at Saltville: Megalonyx jeffersoni. Of course, Greg McDonald's on here, and he's our primary sloth expert in the world, and did his master's on these sloths, as well as his PhD on other sloths. We have short-faced bear represented at Saltville. We have some giant beaver. We have mammoth and mastodon in the most abundance. We have a little bit of horse. We have some elk moose or stag moose, and we have Harlan's muskox, Butherium. And we just had a student this spring, Nick, who was focusing on this taxon as part of his thesis. And so today is very much a background of the history of research there. And we're hoping to have an episode soon that will talk about more updated research. And maybe, Chris, you could just mention some of the different avenues of research that we're doing at Saltville that we didn't have before.
Yeah, so kind of the direction that we've gone in the last couple of years is really to flesh out some of the paleoecological patterns that we're seeing at Saltville. So we've had a couple of master's theses. Emily Simpson did isotopes of some of the large mammals. Nick Brand did geology and muskox of the Saltville Valley. Austin Gauss looked at ostracods and worked with Brandon Curry at the Illinois State Geological Survey on ostracods. And then we also had a senior thesis from Moorhead State University, Maggie Stevenson's thesis with Jen O'Keefe, who is looking at pollen. So we've got a lot of things kind of in the wind right now that probably in the next couple of months, some of those things will be kind of tightened up and put out. So yeah, lots of work right now.
So more to come. And as we move through this, we'll talk a little bit about the geology and sort of the geology and the way that interpretation has changed over time. And it is a little bit different now through Nick's recent thesis. So when we look at the overall diversity of megafauna that we have in the latest Pleistocene here, again, only the black ones have been recovered by bones. The yellow one is actually the dire wolf, which we have some trace marks. We have some bite marks that we think are from dire wolf. So overall, we don't have a great diversity, but we do have a lot. And we can track sort of the knowledge of Saltville in writing all the way back to Thomas Jefferson in the Notes on the State of Virginia. And this piece of work by Karen Carr here shows Thomas Jefferson actually holding a Megalonyx claw. I'm guessing that's a Megalonyx claw. And the way that the story goes is that, he collected fossils, and fossils were sent to him. And when he did this Notes on the State of Virginia, he actually did write about this a little bit. One of the things, though, that he does say is he thought that mammoths were carnivorous. So the mammoth was carnivorous and still exists in the northern parts of America. And so as he's sending people out to explore across the continent, he's expecting this possibility that megafauna, like some of these mammoths and mastodons, are going to be found during these discoveries. And you can see that he certainly viewed them as a monster, a carnivorous monster in a sense, these mammoths and mastodons potentially. And even the giant ground sloth Megalonyx jeffersoni, when he first was writing about it, he thought it was a giant lion, and that was later corrected. But as specifically with Saltville, he said bones of the same kind have been lately found some feet below the surface of the earth in the salines, these salt deposits opened on the North Holston, and specifically he's referring to Saltville. We don't have any of the actual remains from Saltville that he had, though there are remains at his one of his places, I think from Big Bone Lick. The first actual scientific publication, though, is in the 1900s with O.A. Peterson of the Carnegie. And what happened here is some bones were actually sent to the Carnegie. And the reason they were discovered in this case was the well collapse. So down in the well fields of the valley here, you can see that the valley looks a lot different than it did than it does today, actually. They had stripped all the hills of the trees. They had basically used all the lumber throughout the whole region. And these flats were places where they were doing salt mining. And in that process, they had mines collapse occasionally. And so you can look through these well logs and actually see this. But he then went down to visit, and he found some material of his own, and he bought material as well. And so this is where the well collapsed. And here would be essentially the gravels that we will be talking about today, which have a lot of these Pleistocene animals in them. And so one of the questions that we actually have had over time, and we figured out just in the last few years, is where is this well 69 specifically? And so one of the really fun things about working at Saltville is this historical aspect of it all as well. And so on one of my trips to go and see Saltville materials, I went to the Carnegie to look at the fossils, and this is the material. This is everything from the Carnegie actually in this one drawer, but it does have a diversity. It has giant ground sloth, it has mastodon, it has muskox, it has elk moose as well. And so quite a diversity within this sample. So that's at the Carnegie, and that's all that's at the Carnegie. And as we look at the valley today and what it would look at if you were flying over it, essentially, we can sort of see this outline of the valley floor here in red. We've got a nice golf course over here. And then we have these ponds that are holding water. This is actually areas where the valley has been dredged to help keep it from flooding and control flooding in the valley. But right under the surface is the water throughout the valley. And right under the surface is also these Pleistocene fossils. And what we're going to do now is we're going to walk you through and talk about some of these other sites that have been found, like SV1 and SV2, and then the sites that we have been working on up in this area. But we wanted to find well 69, and we were able to relocate it by finding the well logs and lining up the roads. And so you can actually see where these old roads were that are coming across here, lining them up, finding 69 actually on there right here. And then if we remove that, we can see where it is. It's actually right along the trail that you walk through in Saltville between the grocery store here and along the Helen Barber Road Trail, which goes right by where we excavate. And so we've relocated where the Carnegie material came from based on the old well log notes. So in terms of history of excavations, so you go from 1917 up into the 1960s. Keep in mind, though, that people are always finding things in Saltville. Any kind of digging that's going on, these fossils are found. And because of that, material started to collect there over time, by private owners, but also a little museum that started. So Virginia Polytech Institute, or Virginia Tech, started working with the Smithsonian, and that ends up resulting in a 1967 publication by Ray et al. And within that, they give an overview of the fauna and also the flora as well. And as part of that study, they talked about these muskox partial skulls, which are identified as Butherium. And there was actually cores of sediment that were taken out of one of these that was the pollen analyses that were done at that time. And so then if we look at this collection that was built during that time, which is now in the Smithsonian, we can see a lot of these same kind of animals where most of the material ends up being mammoth or mastodon tooth sized pieces. We have mammoth teeth, we have mastodon teeth. Oftentimes they're really well rounded. We've got a really nice ground sloth femur here. And I'm not sure if Greg ever mentioned this in the past, but there's actually a really nice crunch mark on it right here, which I think could also be from a giant short-faced bear. You can see a little more sloth material. This is all basically published in that Ray et al. Paper. And then in the 1970s, early 1980s, local geologist Charlie Bartlett actually became involved with the town in some assessments that they were doing because they needed a geological consultant. He became interested, and in that process, he learned about a skeleton that was weathering out along the Creek Valley there, and it ends up being a muskox skeleton. And he brings in Jerry McDonald into this process, and Jerry McDonald becomes very involved. They end up describing this muskox, which didn't have a head, by the way, as a paper in the Journal of Vertebrate Paleontology in 1983. And they didn't end up naming it to even genus level because of the lack of having a cranium with it. But this really is the catalyst for a long-term involvement there by Jerry McDonald leading the excavations. And so when we talk about the locations, Saltville 1 or SV1 and Saltville 2, SV2, those are two location names that were given by Jerry McDonald, with SV1 being the muskox site and SV2 being a site that's close by right here. SV2 and Jerry McDonald right here overseeing these excavations. And these excavations really became a big part of the town activities and the town becoming really involved in this process, and volunteers, wanting to come back every year and dig. And so the overall process is basically removing the overlying sediment with heavier equipment, and then focusing on the lower aspect right above this gravel, which is also right above this Mississippian age McCready Formation, that you get these late Pleistocene age fauna. And so here we have Jerry McDonald. Again, you can see the excavations in the process here occurring, and they're right on top of the gravel. We'll be coming back to that importance of that gravel here in just a little bit. Jerry's work, the last publication that he did on this site, although I think he's writing a book or was writing a book at least on this site, was this one here published in the journal Jeffersoniana. And it's called An Outline of the Pre-Clovis Archaeology of SV2. So that's the locality. If we look over here, we can see where they went. And SV1 is that muskox locality, with special attention to the bone tool dated around 14,510 radiocarbon years ago. And this specimen becomes very important. So it's actually in big part focused on this particular specimen, but it gives an overview of the overall site as well. And this is that specimen that was dated. And what we're looking at here, he interpreted it as potentially like a piece of a tibia of a muskox, perhaps. So probably Harlan's muskox, Butherium bombifrons is what he's saying right there. And then a drill hole was done and sampled and radiocarbon dated. So that's where that date comes from. In this article, it was interpreted to be the result of human activity, that it was basically a butchered mastodon site. and that there were artifacts associated with this. So that's sort of where things stood in terms of those interpretations. Now, one thing I do want to point out is that our interpretations have been a little bit different of this material. So far, our assessment of these materials is that we would categorize them as basically being naturally caused within this setting and not necessarily being indicative of human activity. I don't know if you want to talk more about that right now, Chris, but we haven't published anything on it yet, but that's my interpretation and what I've seen.
Yeah, that's been my interpretation too. I will point out in that there is one human modification on that bone that's really obvious, and that's the circle in the middle. And so I was just going to point out that that is probably the sample that was collected for a date. So that is a definite sort of human modification.
Yeah, that's exactly right. So this is where the sample was taken for the radiocarbon date, and that is human modification for sure. But what we find is that we get a lot of these bones that are down in the gravel or right on top of the gravels themselves that have these sort of same fractures, same rounded ends to them. So as we then look at sort of time and Saltville, Jerry McDonald then basically stopping work at Saltville, and Ralph Eshelman comes in and starts doing some work for the town with the idea that he wanted to help the town and work with the Museum of the Middle Appalachians, so that's what MoMA stands for here, to keep their dig program going, basically. So they had all of these volunteers that just absolutely loved this experience and kids' opportunities to come and learn about paleontology as well. And so Ralph, who had helped earlier in these excavations, basically put his hand up to come and start helping as well. And he opened up a number of additional excavation areas in the valley. And these are SV3, 4, 5, 6, 7, 8, 9, and 10. So it's adding additional numbers to that system. And one of the things I wanted to point out while we're on this slide right here is that this ends up being a really important discovery right here. And we're going to be coming back to that in just a minute. But that's a giant short-faced bear jaw. It's this one that's right here, okay? So I'll put that down on that one. You can kind of see what it looks like. You'll see it again in just a minute. Another really important site that Ralph discovers is the one over here where he is holding a mammoth cervical vertebra. And this particular site was chosen because the volunteers basically liked this particular area because it was really pretty with all of the flowers. And so that should give you a feel for, an idea for, you can just almost dig anywhere in this valley floor and you're going to find these Pleistocene animals. And so the sole reason why that spot was dug was because it was pretty. All right, so jumping back again, just as a reminder, SV1 and SV2, where Jerry McDonald did his work, and then a number of other localities that we're not showing on here, but to show you now, SV10 is where Ralph found the pretty flowers and excavated and found the mammoth. And then SV5 and SV7 were earlier units that he was working on. And so what happens then is when Stephen Wallace gets here at ETSU, Ralph Eshelman recruits Wally to come up and visit Saltville with students. And so this is in 2003 when they went up there to look at the site and help them excavate. And here you can see the sort of the kind of setting that they were working on over at SV10, again, where the overlying sediment was removed by heavy equipment. And then the diggers get in and remove that uppermost part. And it's just like you're in a mud hole, really. You're muddy, you're sloppy in there when you're in this kind of a scenario. But look what they came down on top of. They came down on top of a partially articulated mammoth skeleton. And you can see from this image over here just how well preserved some of these fossils actually are. So you've got these mammoth ribs, mammoth vertebrae, the kind of thing that somebody like Chris just drools over.
It's like it died yesterday.
It
may have smelled like that too.
It smells like that too. And that's what's crazy. I mean, the sediment smells like that. But then when you cut the bone for any kind of radiocarbon dating, the preservation is extraordinary. It runs you out of the room, or it runs other people out of the room because they think it smells like burning hair. So they just happen to come right down on top of this. Well, Ralph basically talks Wally into taking the project over, okay, and to start getting ETSU people. And Wally was happy to do that as part of this process. So as we sort of come up to speed at that point, then we can say, well, despite all of these excavations and collections that were going on during these past times, very little had actually been published. And the Ray et al. Paper was really one of the most significant, for sure, that combines all of this together in 1967, saying, here are the taxa. And even some pollen work was published at that time, even some geological work was all sort of encapsulated and discussion within that paper. And then we published a paper on the giant short-faced bear and the possible wolf. We'll come back to that wolf in just a second. And of course, we have mammoths and mastodons, our monsters of the site for sure. It's our elk moose. And as Chris mentioned, we're having the pollen looked at again right now. And so that'll be fun to see how that plays out, because we really didn't have a good tie-in with where the earlier pollen studies were done. But overall, Ray et al. Interpreted this as being sort of a spruce parkland mixed with ponds, marshes, and prairies, sort of this iconic setting that we often think about, with mastodons and with elk moose as well. If we look at the Delcourt and Delcourt 1986, you know, what they said: dominant trees, red spruce, balsam fir, tamarack, basically a boreal woodland with marshes across it. So very similar types of interpretation there. Again, we're going to jump back to this just as a reminder that we're talking about SV10. So as we jump back to SV10 and Steve Wallace doing work there in 2003 and 2004, it became this combination project where he was taking students up. They were working in SV10. And again, they weren't even there for very long, just a week or two. And you're basically digging down to the gravel, and you're finding things like complete ribs, and you're finding complete thoracic vertebrae, for example. And they're so well preserved that you're essentially able to just pull them up out of the ground, like the student is right here. So here's that work with ETSU crew back in 2003, 2004. And one of the specimens that I'm going to bring up again here in a minute is this astragalus right here. So this would be the locality if you're at the overlook in Saltville, looking down across the golf course. Again, bones come out of all of these places where people have done any kind of excavations. But this is where Chris and I are working right now, is right in this area. And so I actually arrived at ETSU in 2004, but it was in 2003, early 2004, that Wally put out a hook for me to try and get me over to ETSU. And one of the things that he put out there was this giant short-faced bear jaw. And he actually contacted me originally with that jaw. It's just a picture of it. And he asked me if I'd ever seen anything, or he asked me if I knew what it was or what I thought it was, and if it was what he thought it was. And I said, well, what do you think it is? And he said, I think it's a giant short-faced bear. That's what it was. And it was labeled in the museum in Saltville as bear ? Okay. And so as we come on as a team to potentially start doing excavations at Saltville, one of the things that we wanted to get developed and organized was an excavation plan and a curation plan with Saltville. And so we developed this plan so that we excavate material and we help curate it at our museum at Gray. And that's the way it is right now. So it was really in 2008 that we were really starting to get back in there again. And here you can see one of our past students working with one of the pumps, basically to try and start getting the water out of SV10. And this would be SV10 from that time. So getting down to the gravel area, pulling out more of that same mammoth. And again, it's just in extraordinary condition. And this is what it looks like as you start to get more of that cleared off. And you can really see the contact between the gravel and the clay that's above it right here. And it's right at that boundary where we get most of our fossil material that dates to the late Pleistocene. But I do want to note that even some things that are on the surface, like this partial mastodon tooth, is dating to beyond radiocarbon. So we're getting anything from around 15,500 radiocarbon to beyond radiocarbon right on the surface of that gravel. So there is some mixing that has occurred there within that gravel. And this was the paper that we ended up publishing on this, because what we were seeing is that we have this giant short-faced bear on one hand, the first record of giant short-faced bears from the site, but we also had a record of activity. So this is that jaw that Wally had sent a picture to me when I was a PhD student. So that's one of the things that lures me into Saltville. And then it turned out there was also this canine in the same drawer, and they fit back together again, even though they were from two completely different excavation areas. One was from SV5 and one was from SV7. And at that time, I didn't know how close those two were to each other. And so we radiocarbon dated, and it turns out to be about that same age frame as that bone that Jerry McDonald dated. And what we can actually see here is that picture of that jaw in place, and we can see the rock that was sitting next to it. And as a reminder of our giant short-faced bear being this monster of the Pleistocene, it just was a huge bear that was around. If you haven't heard us talk about these before, we have our Kodiak bear here, we have our grizzly and black bear compared to the giant short-faced bear of North America. And it was actually during one of Greg McDonald's visits when he would come out to see us at the Gray site early on. And we were looking at some of these Saltville bones. So I had already moved out to Tennessee. I was starting up the Saltville projects and what we were going to publish, and showing Greg these bones. He said, well, I wonder if that's kind of looks like a scavenging on this bone. So then, after Greg left, I started looking at after he went back to where he was working, he came to look at our sloth from Gray. But I started looking at these bones again and realized that's definitely what we had. That these actually represent where a carnivore was trying to bite down, and then finally gets a good hold on it. So we're looking at one view here of this astragalus from a mammoth, which would be up here in the foot, in the ankle. And you can see the bite marks. Then if you look at it from the side, you can actually see that big crunch mark that's coming out the side of it. And then you can see the same thing down here. And I've updated our picture with our most recent artistic reconstruction of a dire wolf. And then Wally's original discovery of that specimen back in early 2000s. So that was part of the publication, is that we were saying, hey, this is good evidence of scavenging by carnivorans on this particular mammoth. And not only did we have what matched up perfectly with the cusps of a wolf, but we also had these huge bite marks on some of the other bones. And this included a huge bite mark right through this calcaneus, which if you look at it right here, what you're actually seeing is the movement inward into that spot, and then the opposite side of flaking out of this calcaneus of a mammoth. And we attributed this to most likely being from a giant short-faced bear scavenging on this carcass. And you can see how even the Arctodus canine fits very nicely into that spot if you want to put the two of those together. So another thing that a question that I had, I wanted to move away from SV10 and come back to that later, as I wanted to start searching for where did this bear come from. We knew that there were these two sites called SV5 and SV7, but we didn't know exactly where those were, and it was all covered up in trees and brush by this time. So by getting together with Ralph Eshelman and having him show me the notes that he took and sort of pointing out the areas, we started exploring for these sites in 2010, and then continued on later. And what we first discovered was where SV5 was. SV5 had basically been filled in with plastic and then covered over completely with sediment again. And we found where the SV5 spot was. Here's Brian Compton, our surveyor and museum specialist, and he's right next to a mastodon partial jaw with teeth. And so these excavations across this area, 5, which then ends up running into 7, becomes our primary excavation area. And there's a closer up version of that showing 2 teeth of the mastodon, one worn down and one not so worn. You can see a caribou antler in place there, and the fact that we're doing all of this mapping along as we go. And so what this ends up being is, here's our SV5 area, and we end up digging down through that as our sump, because you have to excavate a sump area, because when you start, water is going to be all the way up to this point in these areas. And so you can get a good view of what we're doing here. We're on top of the gravel. And we were preparing for some filming right at that point, but here you can see the overall area. And to put you into sort of a perspective here, we're talking about, in this case, this being that low spot right here, that is SV5. And then over here is the pond that was left behind for SV7. And so what we are doing over time is moving across that surface, connecting SV5 to the farther SV7. And with this idea that maybe we'll start finding more short-faced bear. And we eventually did. So here is that second lower canine being discovered at that point with one of our students right on top of the gravel. So it was clear that this individual short-faced bear was spread out across the gravel here. And here's what it shows up on a morning, what it looks like when you show up on a morning and the pumps aren't fully in working order. You're still going to be waiting for a while as the water gets all pumped out. But it also gives you an overall view of what the excavation area looks like. Again, you're digging down through these clays until you hit the gravel, and then right on top of the gravel and within the gravel is where you get these Pleistocene animals. But it's just a gorgeous place to work right now, because the trail is also right here behind us. So some excavation pictures from 2013. You have to keep digging trenches through it so the water will drain. And then you have a sump area that you also have to keep a slurry going to keep it cleaned out, actually. So what did you think when you first came to Saltville and you saw this mess, Chris?
I thought I wouldn't leave. I'd get stuck and I'd become part of the fossil record.
You fell in SV10, if I remember correctly.
Yeah. That first year I fell in SV10, and it was strange. I was doing some mapping and trying to fill in some of our maps, and it looked like the bottom was only, it wouldn't go over my boots. But what I found was that was not the case, and I was in up to my chest.
We're lucky we didn't lose you.
Yeah, I almost became part of the fossil record, for sure. Me and the mastodons.
But what we're doing now is, it's a much cleaner excavation area because we're really able to see this large space. And so all of this then ends up being this gravel surface that we just then keep pushing back, and we have these low drainage areas. And we do find materials through that gravel as we're moving forward through it as well. But just to give you an idea of how dense some areas can be, here's one of the mastodon teeth that has been radiocarbon dated right here. Here's another mastodon tooth, a couple other mastodon bones of different individuals, probably another mastodon tooth with a date on it. And these are actually the same specimens that we've included in the ancient DNA study recently as well. And so that's been a really fun surprise, is that not only does it have really good collagen preservation for radiocarbon dating, but this is to my knowledge, our most southeastern locality in the United States where we're getting good ancient DNA, definitely on mastodon and mammoth, and on short-faced bear as well. So more opportunities there for ancient DNA in the future. Just quickly to show you sort of this tracking, all these squares that you see here are squares that we have applied to these units but that's where we projected SV5 to possibly have been. And again, we hit the actual tarp as we were going down through it. And then here's SV7 over here, which was actually a pond at this time when we started working on it. And here we have, looking at Ralph Eshelman's notes, here is where I determined a likely area where these specimens that were recovered in 99 and 2000 to have been from. And then we have the jaw there. Again, those came from 2 different unit areas. And then we eventually have this specimen that shows up right between those 2, right where we hoped we might start finding more. And since that time, we have found a number of specimens right along that same lineation right there over space. And so the bear seems to be spread out over that space, and it's quite a bit of distance. Those are meter squares. And everything seems to be one individual. And this one was one that Laura Emmer got to find. She's actually found a number of the specimens as she's helped to lead some of the, be my crew chief for some of the excavations in the past. But one of the only really nice and well-known claws, terminal phalanges from a giant short-faced bear. But one of the great highlights of that 2013 year was actually rediscovering the rock where that bear specimen came from. And so we can go back and we can look at that picture from 99, 2000 timeframe. And we were looking for that rock, and there it ends up being over here. We find it, it's still in place in the gravel. We were able to take our cast of the jaw, what I have right here, and put it in that exact place and map it in where it was recovered. You know, we're basically removing tons of sediment to refine this locality, but it was such a pleasure and exciting to rediscover that exact locality. So a quick overview from us. We don't see any late Pleistocene human activity yet that we feel confident in assigning. We have at least 2 different carnivorans that were scavenging this mammoth. And Chris is ready to go back to that Saltville SV10 mammoth, and so am I, because there's a lot of that skeleton that's still in the ground. We don't have any leg bones yet. We don't have the jaw yet. We don't have a lot of that animal. So that's a really fun one that we have sort of in our back pocket for the future. We have the spread out of that giant short-faced bear. Would like to find some more of that as well. The youngest ages that we're getting with the gravel is around 14,500. And then, of course, younger dates right above that. We are actually getting some microfauna. Often get that question. That's down in the sands and silts. Some of the material in the gravel is beyond radiocarbon dating, and we're really excited that we're able to be a part of these projects on ancient DNA with a lot of these specimens. So lots is happening. And that's what it looks like when you show up on the first day when nothing has been pumped yet, to give you a feel for how much you're going to still have to pump out. You're talking about another 6 feet of water, 6 to 8 feet of water in some of that hole right there. And it also means taking the animals out. We take the turtles and the fish and the frogs out as much as possible during those first days. And so I'll stop right there and see if we have any questions, and let Chris chime in too as we talk about some of these new projects that we're doing with Saltville. Thank you.
All right, so at this point, I'm going to go ahead and remind everybody that if you have questions for Chris and Blaine about Saltville, now is the time. Go ahead and leave those in the Facebook comments, or again, as I said before, if you can't make a Facebook comment question for any reason, I'm keeping an eye on the Gray Fossil Site Instagram and Twitter account. Earlier on, Grant Boardman chimed in with requisite isotope question.
Requisite isotope question. Yeah, so we are doing some isotopes. We're doing a lot of isotopes on this. We've done multiple animals. We've done mammoths. We've done mastodons. There have been, even before we got involved, Christine France was doing a lot of isotopic work on the Smithsonian collections. So there's a fair amount of isotopic data that's out there. What we're learning is that with the carbon isotopes, this is some sort of C3 environment. It's kind of a smear. So there's not a lot of resolution to that. Emily was also working on testing whether, well, there's an idea that we have these ecological anomalies in the southern Appalachians called grassy balds. And there's a grassy bald not too far away from Saltville. And one of the things that Emily was trying to test with her thesis was, are these animals moving from Saltville up to the grassy balds and grazing on these grassy balds? And so she was using strontium isotopes to do that and didn't find a whole lot of evidence for them moving out of the valley. But yeah, we've got a lot of isotopes, and actually that reminds me, there was actually another student, Rachel Silverstein, who got me involved in Saltville kind of from afar when she was working on her thesis in about 2015. So when I was still at the Illinois State Museum, thinking about a bog or a swampy place, marshy place in Virginia wasn't much of a stretch to a person that was coming from the Midwest, where, you know, at the bottom of every bog you found a mastodon.
We've got a question here from Alton Dooley over on Twitter. Alton says there seems to be a lot of juvenile mastodon teeth at Saltville compared to other sites. Any thoughts on this?
Yes.
It's weird. Yeah. There's, yeah, so one of the weird things about this is that we do have a lot of juvenile mastodons. I've personally, I don't know, Blaine, about you, but I've never seen so many juvenile mastodons in a single assemblage. We do get adults, but there definitely seems to be something that is causing juvenile mastodons to end up in this deposit. They're not all associated with the body. So some of them are shed teeth, but there are some that are, you know, would have gone along with a juvenile mastodon. The mammoths are actually also pretty interesting. So looking at one of the things I noticed when Blaine put the picture of the Smithsonian collections up there, and I knew this, but I had forgotten it, but nice, big, large mammoth teeth that are really nicely preserved. They're almost all the plates are there and that sort of thing. What we have found in SV57 and I don't know if in SV10, but certainly in the gravels, we're not finding complete mammoth teeth very often. We're finding little bits and pieces that are the tail end of a molar that has been shed. So there are some really interesting patterns with mammoth and mastodon age distributions in this. And I know Rachel was working on that with her thesis too. So
I would say at least every year on average, we find at least one baby mastodon tooth that is not a shed. That's actually from an animal that's deceased. You know, that tooth was from when it was still a living animal and then it died. So yeah, I don't think I've seen that sort of scenario in most sites.
Yeah, it's complicated.
But Alton, you had all those years to look at all these teeth at Virginia, and then you moved to California and you start studying mastodons. Give him a hard time.
Spend less time with whales and more time with proboscideans, land whales. Yeah.
Doug has asked, any chance DNA could be used to identify the muskoxen?
Yes, probably. The question would be, well, we do have a good DNA study of muskoxen. So there's ovibos up north. There's some Butherium up north. It just hasn't been done for Saltville. This would be a fantastic place to look for it. The molecular preservation here is fantastic. So yeah, that would be a good way to kind of start teasing some of this out.
Yeah, I think with every one of our extinct taxa, especially that we have, we're trying to partner with people to start helping with ancient DNA studies. So that'd be a good one for sure.
Let's see, Mary has asked, are any specimens on exhibit?
Yes. So first of all, I want to also, give another shout out to the Museum of the Middle Appalachians there in Saltville, which does have exhibits up on material from Saltville. and they have very nice exhibits on sort of telling the story of excavations. So, checking out the Museum of the Middle Appalachians is a real treat for anybody traveling down 81. And we have 4 exhibit cases actually at the museum right now that have Saltville materials on exhibit. So it's an ongoing part of our exhibit interpretation as well.
Yeah, they do have a mounted mastodon. It's a cast, but it's definitely impressive.
Oh, and not only that, it comes in really handy when we're there doing excavation. We take some of our bones and go down and do comparisons with it during the day and evenings.
Charlie asks, is there a particular taxon you would like to discover that has not yet been found at Saltville?
Yeah.
I'm happy. I've got mastodons and mammoths, but I'm sure, Blaine, there's a few things that you want.
Well, we have so few records of Smilodon in the East that just tell us much of anything except it's a Smilodon. Finding something like that in here would be extraordinary. Anytime you can get another Homotherium, that would also be amazing. So yeah, and surprisingly, no tapir. I would expect that we might get tapir down in these watery bog areas. Maybe they were able to get out easier. I don't know. And no peccaries either, which I sometimes find surprising. We find the peccaries in the caves. We find the tapirs in the cave sites, but we don't find them in these boggy sites.
I'll point out that this is actually a continuation of a pattern that I noticed up in the Midwest when we did a whole bunch of dating, trying to understand when mammoths and mastodons go extinct. And what we found was that during the last glacial maximum about 20,000 years ago, in places like Illinois and Indiana and Ohio, all you had were mammoths. There were no mastodons that dated to that time period. And so before I came down here, I was thinking, okay, where are the mastodons at this time? And so the dates that we're getting out of Saltville overlap significantly with that time that mastodons are not present in the Midwest. So they do seem to be kind of pushed down south. And so partly my question was answered. Where are the mastodons? Well, they're in southwestern Virginia. Some of them are anyway.
Good.
So we've got a few more questions here. Greg says, given that the animals were probably drinking the saline water, does that leave a distinctive signal in the oxygen isotope signature? Possible comparisons with Big Bone Lick?
So some of the questions, that we've been challenging students to help us with are, what was the water like? So that was one of the questions. What was the river like? What was the sedimentation like, and those sort of things. And so we've had a student, Chris and I have had some students that have started to address some of this. If you want to hint at what we've discovered, Chris.
Well, Austin, who was working on this, started referring to the locality as Freshville rather than Saltville. So that there's a hint on that. Yeah. So the ostracods were very helpful with that. But by comparing this to something like Big Bone Lick, I know there are a lot of parallels. So having spent a little bit of time at Big Bone Lick myself, and I know Maggie Stevenson and Jen O'Keefe, who were down doing pollen work the last season that we really had a big presence there, have also been working at Big Bone Lick. But this is a very similar kind of site, not only in terms of kind of its context in its stratigraphy, but also in terms of its history. One of the fun things about working at a site like this is you're always thinking about, what did Jerry do? What did, Clayton Ray do? Oh, geez, maybe we're talking about 19th century stuff now. You're never far from the human presence and from the human history and the human excavation at this site, which is it's an enriching part of the investigations at Saltville, I guess.
Yeah, I think, one of the things that we know is that throughout the valley where all these well fields were, that surface became really salty because of the brine coming up and coming out from all the mining. And so, to hint a little bit at what Austin was discovering is that, what we're seeing on that modern surface in that modern water isn't necessarily what it was like during the late Pleistocene in terms of the water.
the ostracod record was really cool
Yeah.
and surprising.
Yeah. Stay tuned.
Olga asks, what methods do you use for mapping the finds and the stratigraphy of the site, considering the MIS 2 to 4 span, for tracking the faunal change?
So I'll take a stab at that first. As we're looking behind, so this picture is some of the education and outreach that we do to give you an idea that, again, it's so accessible because we're right along a trail and a road that we can really be an educational setting. And Jim Mead was my partner here working with this site for many years too. And so he would have been here this year helping. But as you look right behind me, you're going to see I'm standing on top of this pavement of gravel, basically. And then there's this sharp boundary where the clays begin. And almost all the fossils that we find are in the gravel or just right above the gravel itself. And right above the gravel, they're going to be 14.5 or less. And then down in the gravel, they're going to be 14.5 or even much older. And so we're not able to, we're getting this time averaged surface where we're getting most of the megafauna. And I think we're still in a stage of trying to understand the sedimentology above the gravel at this point. Chris, you want to comment on that?
Yeah, this has been really a place where we've spent a lot of time thinking about it. And Nick Brand and his thesis project was looking at the origins of the gravel themselves. And I think the next steps are really to understand the sedimentation and what's going on above it. One of the things that was suggested early on, well, there are multiple suggestions early on, but one of the working hypotheses was that we had some sort of fluvial event or river valley that was redistributing these gravels all over the place, and then that stream was pirated away and it turned into a lake that was infilling. We've the details of that and even some of the broader strokes we're starting to question, and but the fact remains that we have these very different stratigraphic units, and they do more or less have some chronological coherence, but the gravels are definitely a mixed and reworked deposit. We see mastodon teeth that have been abraded and broken in half, but then they're also pristine within those gravels. So they're getting knocked around a little bit, but not all the time. We're getting 40,000-year-old plus mastodon teeth right next to 20,000-year-old mastodon teeth. So it's a complex deposit that's kind of fun to sort out.
And as you look at the surface again, right there, those gravels, when I started working there, the idea was that this was a fluvial deposit. This was it was even called the Saltville River given that name into the past. But as we got down and we were able to see more and more of this gravel and really see this exposed surface, it just didn't appear to be a river setting. And if it is river gravels, then it looks like it was deposited from somewhere else. And so those were sort of the questions we were throwing out as Chris came aboard in 2017. Also happened to be a year where we were celebrating Saltville because it was 100 years since that publication by O.A. Peterson. And so we brought in a bunch of people to look at it and start getting ideas on what we could do to test it, what we could do to get a better understanding of it. But realize that gravel itself can be a meter thick, or it can be nothing. It can be just a little bit of sand on top of the McCready Formation, which is Mississippian in age, which is actually an overturned bed as part of the orogenic development of the Appalachians. So you've got a real time difference, a real unconformity right there between those gravels and that Mississippian aged material underneath it, which also has these evaporites in it as well. And just a couple more. Oh, there's Jim, doing some of our outreach. So when we do programs up there, we do a couple of kids' days usually. So if that's something you're interested in the future, hopefully we'll be back to doing that before too long. I wanted to throw this picture in because my interpretation of the way that this bear, here's a monster for sure, is whenever you look at this bear, at Saltville. And then you look at these huge bite marks that are occurring. What I wanted to develop was an image that looked like a bear scavenging a mammoth in a lake, trying to basically keep its head above the water while it's scavenging on this mammoth. Because I think this bear was going into the water, into standing water, to actually get at this mammoth. And that's why we're seeing the types of scavenging that we're seeing. So that's my hypothesis about that type of deposit, where that mammoth actually is, that was more of a bog or lake type of setting where it was. But this is not a finished image. This is still an image where the artist Karen Carr is still working with us to recreate what this may have looked like. In this image, it looks like a monster bear with the Himalayas in the background. And so we still need to work on changing the face and the way the teeth are structured, and downplaying the mountains in the background. But definitely a scary looking animal out there, this one here. Other questions?
We are just about at the hour mark here, but we've got just a couple more questions in the audience, so we can get through these quick. Amy says, you mentioned salt-like versus grassy bald. Do you have any C3, C4 isotope studies or phytolith studies?
So the C3, the carbon isotope studies basically are indicating everything is a more or less forested environment. We don't have a lot of C4 on the landscape, which, so the way this pans out, carbon isotopes are teasing apart two different kinds of plants. On one end of, when you have high carbon isotopes, it's C4 plants, and those are all grasses, so warm season grasses. The other side of the spectrum, as you get more negative carbon isotopes, then you end up with C3 plants, which can be a mix of cool season grasses and or shrubs and trees. And so what we see kind of across the board at Saltville are these animals are in a C3 environment. That doesn't mean that they weren't going up to the balds, because there could have been cool season grasses up on the balds or something like that. But the reason that we don't think that they're actually going up to the balds is because of the strontium isotopes, which is measuring kind of the underlying geologic signature that these animals were traversing as those teeth were forming. So that will be another talk, which will be a lot of fun.
And then finally, this will be our last audience question. And then I've got a question I'm going to ask. Grant says, where do you put the turtles and fish? Presumably referring to the living ones you have to pull out of the pond.
They just get picked up and moved over to the water on the other side. So we just don't want them to get caught up in the pump. So we take them out, and we identify them, have a little bit of fun looking at them. This is with the turtles primarily, not the fish, and then move them over, just 50 feet over to where the pond is on the other side of the walkway. Yep.
And then I've got one question just before we wrap up. One of the things that I always like to think about when we think about Saltville is how our crew works the Gray Fossil Site and Saltville. And there's all these great parallels. You have two different ages, slightly different location. But as you were mentioning, there's also, Saltville is this very historic site. So could you comment on what is it like to be able to work simultaneously on a site that is brand new, and you're the crew that is starting it at the Gray Fossil Site, versus a site with such an extended history like Saltville?
Hey, Chris.
It's, I don't know. I think it's humbling in some ways. To me, working at Gray, you're constantly thinking, okay, are we doing it right? We're the first ones, we're the only ones. We can't really lean on anybody that came before us. And so we really think about things. At Saltville, you're stepping in the feet sometimes of giants. And it's fun. You're always kind of trying to get into Clayton Ray's head, or trying to get into Jerry McDonald's head, which is it's a different experience. Yeah.
Yeah, I think it's really fun to work at Saltville, because in that historical way, because you're thinking, well, what did they think when they were here looking at it? Where was Peterson, when he came? And being able to find that exact locality that was the collapsed well number 69 was really rewarding. Being able to find the rock, that Ralph Eshelman uncovered in late 1990s, early 2000 timeframe, and then refine that rock was incredibly exciting. So you've got the paleontological side meshed with the historical side that I think goes perfectly with that town too, because their museum goes, from prehistory all the way up through the Civil War story, all the way up through rocket fuel, and basically being a Superfund site, and now being a wonderful tourism place. And so it's a place of great deep history of both paleontology and history and prehistory.
Well, great. Well, I think that's all the questions we have. I think that's also all the time we have. So thanks to everybody who joined us and watched us and asked questions. Chris and Blaine, is there anything else you guys wanted to say before we wrap up?
Join us when we get back there. Yeah.
Yes.
This
Yes.
summer we probably won't be draining a pond too much, but hopefully someday in the future we'll be back, and we'll be looking for volunteers.
Every paleontologist should get experience at Saltville. Every aspiring paleontologist should get to smell it and feel it, experience it in all those
Yes.
ways.
Crawl around in the mud.
Yeah, for sure. All right. Thank you, everybody. See you next week.
Thanks, everybody. Bye.
Bye.